So good morning, everyone. So for today, we're gonna implement the SimCSE, which is stand for the Simple Contrastive Learning of the Sentence Embeddings. Before we coding, we try to understand first what is this paper try to do. Okay, we go to the paper first, and we can look at the abstract. So yeah, the things that they want is like the supervised learning. The idea is just take the input sentence and predict itself in the contrastive loss. Okay, but the different thing just only use the drop out, which is we do something as a noise. Okay, so this is the idea that they try to predict itself because they doesn't have a label that try to control the losses. And yeah, they say that in order to use the contrastive loss learning, we can have an entailment, which is a positive pair, and a contradict as a negative pair. But what does two of these mean? We can look at over here. Yeah, let's say we have two different embedding, which is the positive pair. Actually, it's just input sentence by itself. But when we want to use the negative pair, we just say that, oh, we use the input sentence and we just use another input sentence from each sample, different sample. Yeah, this is the other sentence in the same mini batch. We just call that is a second negative. So the idea from this one is like, maybe we can go to the architecture. Yeah, over here. So let's say this is the input sentence. So we just make this one as a dot mask, and we make another one a dot mask, but different dot mask. Okay, and then we just use two of this to the function similarity. Okay, so we call this one as a positive. Yeah, you can see the arrow. And another one, we just use this input sentence as well, and use another input sentence, and we try to combine this in the cosine similarity, but we call this as a negative pair. Okay, we call this as a negative pair. So if we look at the losses, you can see that from the top, okay, from the top, it's just input sentence at itself, but it's a different mass. And the lower one, yeah, this is all of the negative pair. Okay, you can see this one is a HI, which is come from the input itself, and HJ. Actually, this is a positive as well, but we call that this is not the same input sentence. Okay, not the same input sentence. So we can see that in the each batch, okay, we have to pair input and another input and make some of them and compare and put inside a negative part. Okay, so this is the idea. So yeah, in this paper, they try to use P10 bird. So I'm going to try to use a bird and follow the things that they do as well. Okay, so maybe we can get started. Yeah, so first, yeah, just add the proxy and set the CUDA first, because for now I use buffer. So I want to set to use only the GPU number one. And yeah, so for in this case, you can go to this one. They're gonna provide about the dataset example for the SimCSE. You can see that we have only the text. Okay, we doesn't have any label, or you can download inside. Yeah, if you want to use the Huggingface version, you can use this one. But for my case, yeah, I try to download them. Yeah, I put in over here. Yeah, yeah, and in this one is the text file. I list text file and set that, oh, actually, because it doesn't have a sort and target, right? So I create a sort and the target, which is itself. Okay, and I pair of them and put inside the data set. Okay, but in this case, I try to separate them. First, in this case, I use test data set only 15%. So you can see that, yeah, this is 10 dataset site and the test dataset site. But yeah, it's quite a lot. I cannot train in like whole process. Okay, I just pick up only like 10,000. Yeah, I select only 10,000. And for the validation, just use only 1,000. Yeah, that's quite small already. And yeah, let's say we check this one. Raw dataset 10. Yeah, it's the same thing because they try to predict itself. And next, yeah, I just call bird based uncapped. And yeah, we just want to use tokenizer config and call the model. So now we have a bird model. And yeah, in this one, I doesn't use any downstream tasks, okay, because we want only to get the text embedding to the final product of the bird model. So you can see that at the last of line, we have only the puller, which is embedding, the final embedding, before we can do any downstream task, okay, but I want only this. And yeah, so from the top we have source text and target text. So I want to separate both of them and say that, oh, yeah, you have to padding, and set the padding size it's 32. And yeah, we have 4 of them, which is come from the inputs and marks between source and target. Yeah, after we get this function and map already, yeah, I have to remove them as well. But for this case, you can see that I doesn't have any labels, yeah, because it predicts itself. So then just put into the data loader. Just said for now use batch 16, and for the tail loader just shuffle them. And the college that I use is only the default one. I doesn't change anything. And yeah, to check the batch first, does it match anything or not? Yeah. So for this case, I just make a puller again, same as the sentence bird. Yeah, to operate the bird and the robot bird to fix size of the sentence embedding. And then in this case, I just use only Adam as an optimizer and set learning rate a bit and set some warm up. Yeah, and this is the part that calculate the loss. Okay, so for the losses, so for the contrastive loss learning, we use similarity. So this is a similarity. You try to multiply between 2 hidden output and pair with the side of them. And yeah, we have the top as a positive and the lower as a negative. So you can see that if we look at these losses in this into the positive, okay, we just use palm and a set palm, okay, and divided by temperature. This is a positive thing. Okay, so it means that we have all of the positive, okay, but this one is all of the batch, okay. Okay, so in another one, you can see that for this case, I have a negative. I want a negative, so I just unsqueeze the input text first, and then compare the cosine method between the palm that we have. So now we're gonna have the negative pair, okay, inside this one, okay, and yeah, so we just put into the log submax. So to matching between negative and positive, so I have to unsqueeze the positive as well and matching with this one, okay. So then we can get a log for the positive now, but you can see that for the log negative likelihood for this case, I want only the positive pair for each one, right? So just select all things, and we just use only the first index of the each positive pair, okay? So then we can have all of the each pair, but it gets only the positive one for the things that they predict and predict itself. And I just get the mean of them. So you can see that this is the example, like let's say we have a bad side 16 and embedding dim is a 76. So let's say if I maybe let me type, okay, let's say I try to make a random between Z and Z palm, okay. So you can see that the shape between of them is almost the same. And if I use this one, yeah, we doesn't have a temperature or anything. Temperature one. Okay. So you can see that this is the positive pair that they try to check for the each pair. Okay, this is like first sentence, second sentence, and so on. But for the negative pair, let me show another one. Okay, So you can see that this is quite a lot. So what does this one mean? Yeah, so because we have squeezed, maybe let's look at this one first. So you can see that we had unsqueezed to get another side between this one. So it means that they matching the last of output between this and this, and we get this one. So you can see that this, I think this one, the shape is a 16. Maybe we can check here first, like what is the shape? Yeah, it's a 16. What does it mean? Is like they try to map as a table between the pair. Every pair that they have is like a pair itself and another different batch, because this batch is 16. Every sample have to match another sample, so then we can get so for each batch you can see that if we look at this is the first batch, but this one they try to compare everything's inside the so the mini batch inside. Yeah, and then just make this one to matching with unsqueezed and get the losses. Okay, so you can see that yeah, they can keep a losses for us. And yeah, for this case I try to train with the 5 epoch, and yeah, we have data loader, and I just separate the inputs as A and B and attention A and B. Yeah, we just put inside the model and get the token on the last hidden state. Okay, so we get the last hidden state, we just put into the mean pool, and we get the final output from the mean pool to contrastive loss learning, and make it them 10. But you can see that I think you can see that in this case the loss that I have just only 2. It doesn't improve much, I guess, but it actually just improved already. But I think for the unsupervised learning you have to try to use a lot of the training, because for my case I usually use only 1,000, but they said that they have in real cases like 1 million. Yeah, you can try to implement more, like if you use a more sample into the data set, does it improve the loss or not? Okay, and yeah, in inference I just use the same as a training, but I just change from the loss for the contrastive loss learning to check the cosine similarity instead. Okay, so you can see that from the loss that they have, yeah, they does not improve much, but when we check the accuracy from the cosine similarity, they said, oh, it's 90%. So it's like they try to understand itself and say that input sentence and itself is quite similarity already. But in case that when I try to inference, okay, it actually just copy the text, okay, and put into some function. And let's say if I have this sentence, okay, sentence A is like, your contribution help make it impossible for us to provide our student with the quality of education. And the second one is like, your contribution will of not help with our student. So you can see that this one, I try to make this positive things, and make another one is the negative things. So you can see when I try to make a sentence, yeah, they say that, oh, it's a 50%, but yeah, let's say if I try, but this is a negative, okay, so I try to positive. So you can see that this one they can set like only 50% or 60%. They cannot improve a lot, because the sentence that they have or the things that they train that's not the same. Okay, so if you want to improve this, you can try to have, initially if you see this one, okay, and this one they try to improve itself, right? But the case that you want to apply, maybe you can have like a pair of the data set as well. Like you have let's say if you have a label and the target, so then it can improve a lot. But the things that they different is gonna be something like this. From the unsupervised learning is gonna be supervised instead. So you can see that let's say you have input sentence is like 2 dogs are running, but you have a label, but the label in this one is like there are animal outdoor, or the pets are running on the call, something like this. Okay, so you can change from the unsupervised to supervised as well. Yeah, that's it for SimCSE, I guess. Yeah, but for this lecture, the things that we try to understand is this one, contrastive loss learning. Like, let's say we have a pair, how we're gonna make positive thing and the negative thing. Okay, that's it.